This is CPM Math 3, Problem 1-83. We are being asked to graph a function y equals the cube root of x plus 2. And we're just going to use a table. There are other methods. There are some shortcuts that we do have available to us eventually, but we're just going to really think about inputs and outputs. So I know that cube roots can be a little bit tricky. We can use a calculator in order to find outputs and approximate, but I'm going to try and stick with integers here and try to force numbers inside our radical here to be perfect squares. So I know 1 times 1 times 1 is 1, and 1 is a perfect cube, excuse me. And 2 times 2 times 2 is 8, so 8 is a perfect cube. And 3 times 3 times 3 is 27, so 27 is a perfect cube. So that's kind of a starting point. Let's try to force that to happen as an output within the radicals. All right, because cube root is kind of unique, I do have a couple of inputs that I think are going to work. Let's do -1 first. When I do the math and input -1 in for x, I end up with the cube root of 1, so y equals +1. So we have -1, 1 as one of our points on this graph. And when I put 6, I chose 6 very strategically because 6 plus 2 is 8, and the cube root of 8 is 2. So if 6 goes into our little function machine, then 2 comes out, and that is another point on our graph. And when I take, I'm actually going to skip 25 because that's kind of beyond my graph that I have available here. So I'm choosing -3. So -3 plus 2 is -1. And normally we wouldn't like a negative under here if this was a square root. But cube roots are different because -1 times -1 times -1 is -1. So we actually get an output here of -1, the cube root. Okay. And again, another very strategic input, -10. -10 plus 2 is -8, and because it is cube root, I'm using -2 times -2 times -2, so my output here is -2. So -10, -2 is a point on our graph. And we can kind of see, we've been experiencing kind of what the graph of a cube root looks like. And what's going to happen here is I'm going to get this little hop and over in my graph like this. So let's see what that looks like. I need to make sure my little guy's here. All right, so it's going to go, ooh, be careful. And this is a sketch. Whoops, that's kind of jig-jaggy there. And that's going to go on and on forever. So that's kind of what it looks like. We just use some inputs and outputs, and there we go.